Question 2 of Paper 2 for June of 2024. 50 athletes need to access suitable training facilities. The table below shows the distance in kilometers that they need to travel to obtain access to suitable training facilities. And here we have our distances as intervals and the number of athletes that occur in each of those intervals. 2.1. Complete the cumulative frequency column provided in the table in the answer book. So in your answer book, you'll have the same table with a cumulative frequency column. So in our first line or first interval, we have a total of 3. Then for the next value, we need to add 3 and 7, so that is 10. And I continue doing that for each line. So the next will be 30, then 42, then 47, and finally 50. So you can check your answer because at the start of the question it said 50 athletes, and that means the last value in my cumulative frequency column is supposed to be the total. 2.2. On the grid provided in the answer book, draw a cumulative frequency graph or OGIV to represent the above data. So in your answer book, you'll have a grid, but let's go through some of the basics here. Firstly, you start off your OGIV with the lowest value in your interval. So if this number was, for example, 2, then the grounding here would be at 2. Next, the points that I plot, other than the first one, would be the highest value in my interval. So the first point would be at 5 and the cumulative frequency of 3. So for a distance of 5, I have a cumulative frequency of 3. Then for 10, I'll have a cumulative frequency of 10. So notice I'm plotting the 10 and not the 7. And I continue doing this for every value in my cumulative frequency column. Also, what I want you to notice is that when you draw the OGIV, you do not connect the dots with a ruler. You need to show that it is a curve. Question 2.3. Calculate the interquartile range of the above data. Now, to find the interquartile range, you would need to use the OGIV which you have produced. So first, we need to find quartile 1. Now the position of quartile 1 is a quarter of the way of the total number of athletes. So it is a quarter times 50, and that is at 12.25. So on the number of athletes, I try to find where 12.25 would be, and I extend the line with my ruler. And I go straight down to find the estimated distance. So 12.25 represents the position, but it looks like the estimated value for quartile 1 is around 11. So I interpret the information from this x-axis. Now let's do the same to find quartile 3, which is 3/4 of the 50 athletes. So that is 37.5. So that's the position of quartile 3. So on my y-axis, I would find 37.5, and I'll use my ruler to extend that to my curve, and then I go straight down to the x-axis. So it looks like the estimated value for quartile 3 is around 18 or maybe even 19. So these values do not need to be totally accurate because we are estimating it. As long as you find the correct position and then use your ruler to estimate these values. So to answer question 2.3, the IQR, it is the difference between quartile 3 minus quartile 1, and that is 18 minus 11. So we estimate that the IQR value is around 7. 2.4, the families of 4 of the athletes above who stay between 15 and 20 kilometers from a suitable training facility decide to move 10 kilometers closer to the facility. In which interval will the number of athletes increase? So this question tells us that 4 athletes between 15 and 20 kilometers move 10 kilometers closer. So if you take 15 minus 10, that gives you the interval of 5 to 10, or you can say 20 minus 10. Either way, for question 2.4, the number of athletes will increase in the interval of 5 to 10. So you can just write down this interval as your answer. 2.5. Calculate the estimated mean distance that the 50 athletes need to travel after the 4 families have moved 10 kilometers closer to the facility. Clearly show all your working. So first we need to move these 4 families. So in the previous question, we identified that they move from the interval of 15 to 20 to 5 to 10. That means that interval of 15 to 20, we would lose 4 athletes. And in the second interval, we would gain 4 athletes. So the new frequency would be 11 in the second interval and 8 in the fourth interval. Now I can use these new values with the original values to find the estimated mean. So remember, for the estimated mean, we would use the midpoints of our intervals. So the estimated mean is equal to 2.5 times 3, that's the first interval, plus 7.5 times 11, which represents the midpoint and the number of athletes in the second interval, plus 12.5 times 20, plus 17.5 times 8. So remember, this 8 now is the number of athletes in this interval, and 17.5 is the midpoint of that interval, plus 22.5 times 5, and then lastly we have 27.5 times 3. And I need to divide this by the total number of athletes, which is 50. Therefore, the estimated mean is 13.5 kilometers. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.